Good morning, everyone. My name's Dean Orchard. I'm the Managing Director of Sydenham's Timber Engineering. I'd like to be here today talking to you about the advantages of timber frame, the thermal advantages, the speed advantages, but unfortunately I've been given the unenviable task of talking about timber frames and fire risk management. But hopefully we'll all learn a little bit about it today. So, putting fire into perspective. Well, the HSE estimates there are around 11 construction fires every single day. The construction industry suffers losses estimated at 400 million a year, which is 1 million every day. And 2 out of 3 fires in construction industry premises are started deliberately. Motives range from revenge to fraud, crime concealment and vandalism. So, is it just timber frames that are vulnerable? Well, no. All buildings under construction are vulnerable. Brick and stone flake and disintegrate. Exposed timber frame structures could burn and generate a lot of radiant heat, which is a lot of what I'm going to be talking about today. Concrete can be subject to explosive spalling and steel can buckle in severe heat. So it's not just timber frame. And a lot of what I'll be talking about today applies to all building types, not just timber frame buildings. Okay, so why has timber frame been highlighted recently as a particular fire risk? Well, it's largely to do with a couple of big fires, one of which happened in 2010 in Peckham. This fire was on the left you can see a picture there of a 5-storey timber frame under construction. Now it's at this point when the timber frame is most vulnerable. Once the timber frame is a plasterboard covering or brickwork on the outside, it's no more likely to catch fire or burn any more aggressively than any other type of construction. However, they are vulnerable during the construction stage. Now what you're seeing here is a timber frame building fully ignited, and on the right a block of flats within 30 metres of that building, which also caught fire due to the radiant heat from the source fire. So this is the problem, one of the problems we're trying to eliminate with timber frame during construction. But despite the high-profile fires specific to timber frame construction are very rare. Because timber frame is erected so quickly, it mitigates the amount of time that it's vulnerable to arson, tackle or otherwise. And the key is to reduce the possibility of a fire event by strict site management and good site security. So, what has the industry done about these fires and the bad publicity that timber frames receive due to these? Well, 90% of the UK timber frame manufacturers are members of the UK TFA, which is the UK Timber Frame Association. They've just changed their name to the STA, Structural Timber Association, but for this presentation we'll stick with the UK TFA. So they've basically looked at producing a document called Site Safe, which is designed to sort of manage the process through the timber frame. But, and there's a big but here, this guidance, and I will say it is guidance, it's not mandatory, it's guidance, is for large projects as defined as those of 4 storeys or more and with an aggregate floor area of greater than 600 square metres. So what does that mean in real terms? Well, if you were building fairly straightforward box type houses, you could build 8 of those houses on any given site before you would actually need to introduce or consider Site Safe. Or you can see there 3 storeys, 6 flats, reasonable sized projects. So projects smaller than this don't need to be considered under Site Safe. So what does Site Safe actually do? The Site Safe process brings together guidelines laid down in the following documents. And this is interesting. The first document is the UK Timber Frame Association's Health and Safety Policy. The second part is the 16 steps to fire safety, which is what I'll be coming on to later on in the presentation. And the other documents, fire prevention on construction sites, the good old CDM, which hopefully most of you are aware of, and the HSE document, Fire Safety on Construction Sites, revised 2010. So the guidance is based on documents that are already in place and should be adhered to by the construction industry as a whole, not specific to timber frame. Okay, so moving on. So, Site Safe is put into 3 stages. The pre-construction planning stage, prior to site delivery. This is where we try to mitigate risk in the design process, so this is the important stage for architects and designers. Then you've got stage 2, which is when the actual timber frame arrives on site and is being erected. And there's a 16-step document that I'll be going through that explains that. And stage 3 is when the timber frame is complete, but the building is ongoing. So the timber frame erectors have gone, your timber frame's up, but you still need to keep certain fire things in place once the timber frame's finished. So, pre-construction planning. We've got an obligation now, as a member of the UK TFA, to write to the principal contractor, whoever that may be, to request the CDM coordinator's details. So on larger building projects, a CDM coordinator should be appointed. The member, again, must write to the CDM coordinator to inform them of the member's company's identity and notify them that the project falls within the scope of the site safe rules. And they must ensure that the principal contractor's fire plan is in place. The build sequence and handover procedure is to be established and agreed between the member and principal contractor, and the member must notify the chief fire officer of the relevant regional fire authority of the project. That's done as an automated process now online. Any project that we're involved in bigger than 600 square metres or more than 4 stories, we have to notify the regional fire authority, and that's done through an online process. Okay, so I mentioned the pre-planning construction stage, which is relevant to architects and designers. Now, I mentioned before the Peckham fire, the problems with radiant heat. So the idea is to mitigate that, is to design buildings that are either at a certain distance away from neighbouring buildings, or they're fireproof to an extent they can be, the distances can be reduced. So as it's set out in the document, you have an emitter and a receiver. The emitter being the building that could potentially catch fire, and the receiver being the neighbouring building nearby. And what they've done within the code is they've broken it down into 3 categories. You have a category A, which is a standard open panel timber frame construction, which is what most people are used to. So basic, straightforward stud panels, OSB sheathing, joists, whatever they may be, metal web, I-beams, softwood. So that would be the standard category. They then go for a category B timber frame, which is a reduced fire spread timber frame, which I'll lead on to, and a category C, which is a fire spread resisting timber frame. Categories B and C are subdivided into smaller categories, B1, B2 and B3, and category C into C1 and C2, but I'll come on to that on the next slide. So what does that mean? Oh dear, I don't think we can see that very well, but what you've got is a category A frame, as I've just described, bog standard timber frame as we all know it. Then you've got a category B type of timber frame. Now a category B timber frame, you can pre-treat the studs with a fire retardant, flame retardant, and you can use a sheathing on the outside of the studs of limited combustibility. I won't go into the floors at this stage, I'm going to run out of time, but then you've got category B, which is, category C, which there's 3 options on that, but the basic option, I think the option that most timber frame suppliers are going to actually adopt, is the use of a non-combustible board to the outside of the frame, such as a Thermocell or one of the magnesium-based boards that can be applied to an OSB. Now, category C gives the best fire spread resistance, and we think by just simply changing the OSB that we traditionally use to a different type of non-combustible material on the outside of the panel mitigates most risk, and that's borne out in the tables that you're just about to see. So going forward, how the calculation works. A new frame, a timber frame building in plan. EL represents the emitter length, so the emitter length has got to be considered. So you're looking at a building, for argument's sake, that's 14 metres long. At this stage we don't know the distance to the receiver building, but using their charts, now this is for a category A timber frame, so you can imagine your site plan, you've positioned your building, you're looking around seeing what adjacent buildings there are. If the building was 14 metres long, so greater than 10, less than 15, and 3 stories, we arrive at a distance of 16 metres minimum between your new timber frame and neighbouring properties. Now that's a significant distance, you know. Most sites you'd expect a building to be within 16 metres of you. So in this situation, taking this example using a category A frame, you're probably not going to comply for most sites. So then you need to consider other options. So looking at a category B1 frame, so a fire retardant stud with a semi-combustible sheathing. If you apply the same rules, 15 metres, 3 stories, you're looking at 12.5 metres between your emitter and your receiver building. A B2 frame is pretty much the same as a B1, but with the addition of additional insulation in between the studs, so you get slightly better values. again, using our rules, 15 metres, 3 storeys, you can then be, if you're using a B2 type frame, 10.75 metres away from the neighbouring building. Having said all that, I don't think many people are going to adopt a B1 or a B2 frame in a situation that's vulnerable to fire. I think people are going to be looking at, Sydenhams are certainly looking at a type C1 or C2 frame. So type C1 frame, non-combustible material to the outside, will then give us 15 metres, 3 storeys, a distance of 5.75 metres away from neighbouring buildings. So looking at that, you'd think to yourself, well, most neighbouring buildings on typical sites are going to be at least 5.75 metres away, so we have fairly comfortable compliance. But you may ask the question, well, what happens if we're actually building hard up against another building, or within a metre or two, which does happen on in built-up areas? Well, then we'd introduce a category C2 frame. Now, a category C2 frame is exactly the same as a C1 frame, but the openings are actually sheathed over. So any window openings, apertures within the external envelope are actually sheathed over completely. Now, that creates problems in itself with the means of escape and light within the building. But you've got to think to yourself, well, if I'm within tight up to another building, I'm not going to have any windows, or it's unlikely I'm going to have any openings in that elevation. And then the C2 only has to be adopted for the elevation that adjoins the other property and for 5 metres back on the flank walls. Then you can go back to adopting your C1 frame. So if you liken it to perhaps another, say the block industry, what we're having to do is we're having to come in line with new regulations or guidance, and the way we're doing it is to change possibly 1 or 2 of our products. The block manufacturers, for different reasons, thermal reasons perhaps, have had to introduce different materials in addition to their normal blocks, thermal boards, extra insulation. So all we're doing is improving our product to come in line with the guidance that's set out by the UK TFA. What we think is going to be a fairly minimal cost. Okay, that in a nutshell, it is a bit more involved than that, but in a nutshell is the pre-planning stage. Now, I'm going to apologise in advance if this gets a bit wordy, this section. It's very difficult for me to quote 16 steps without actually reading verbatim at times, but this is the point of the project where you're actually starting on site erecting the timber frame. And a lot of what you'll see within these 16 steps is not specific to timber frame. It's in your CDM regs, it's in your fire safety and construction HSE regulations. It just so happens that it's been highlighted and included in the site safe policy. We should all be doing it on all sites anyway, on larger projects. Okay, so just a flow chart there of the 16 steps. Okay, step 1 is to comply with CDM 2007, which I believe is being updated and is going to be released again next year. The Construction Design and Management Regulation 2007 CDM came into force in Great Britain on April 6th, 2007. It applies to all construction projects where people are at work, so not specific to timber frame at all. It places legal duties on virtually everyone involved in construction work, and compliance includes producing a risk assessment for the site, its design and construction, covering the use of any building material. Again, not specifically timber frame. And assessing the fire risk and potential for damage to ensure these are kept to a minimum during construction. The other obligation is to appoint a fire safety coordinator. We think it's the best practice for the fire safety coordinator to be appointed for all construction sites. Large projects should also have a fire marshal and deputy fire marshals, and under CDM regulations every construction project should have one duty holder who is responsible for creating and regularly updating the fire safety plan. Again, I would imagine this is something that we should all be doing, and at times, you know, we just don't consider it. It is vague in the document as to what stage these things need to happen. They refer to it often as a larger building project, but nevertheless, it's something that we all need to be aware of. And we recommend that the person is also the fire safety coordinator, whose role includes liaison with the local emergency services and other duties. Step 3, you should all produce a fire safety plan. This is a written plan setting out everything to be done on the project to minimise the risk of fire and to protect the people working on site. It must be updated at regular intervals during the construction process and whenever significant design changes occur. And during construction, it's the responsibility of the principal contractor or the fire safety coordinator to ensure that all procedures, precautions, measures and safety standards in the plan are clearly understood and complied with by everyone. Again, you can refer to the Joint Code of Practice for more information on that. Step 4, check, inspect and test during the construction process. The way the document reads, as long as there's a system in place for checking, it doesn't matter if it's daily or weekly or the end of each day or the end of a shift. On certain projects, larger projects, where 24-hour security is required, fire checks should be done throughout the night, as well as during holiday periods and weekends, and this is times when the buildings are obviously most vulnerable. A lot of this, as I said in the first place, is guidance. Don't be frightened into thinking you've got to have site security on every building project you do, or even some of the larger ones. If you're building in the middle of London, you would be thinking to yourself, well, site security is probably a reasonable thing to have. If you're building a block of flats in Brighton, then you're not going to be considering 24-hour site security. And again, it's all about keeping and maintaining records and fire drills and other procedures. Communicate and liaise, step 5. Effective communication and regular liaison with other parties such as emergency services and security personnel is extremely important in assessing and managing potential risks during construction. And the principal contractor or fire safety coordinator on any site should liaise with the local fire service at an early stage to invite them to undertake site inspections and familiarisation tours. For large timber frame projects, there must be a specific discussion with the fire service to verify and maintain the source and capability of water for firefighting. Fairly obvious things, really. So step 6, promote a fire-safe working environment. Again, all these things should be done on every site, not just timber frame. But the principal contractor or fire safety coordinator must ensure fire safety processes and precautions for the site are fully maintained throughout the entire period of construction and must promote a fire-safe working environment. Again, working with site management and subcontractors. There's also a point which I mentioned earlier at which the building is handed over by the timber frame company, the timber frame's finished and erected, and at that stage, if there are things like subdivision walls have had to be introduced, fire break walls, that has to be maintained. Just because the timber frame guys have come away from the site doesn't mean that those things should be kept in place. Okay, step 7, make sure your fire detection and warning systems work. I'm not going to read all the way through that one. I think it pretty much says it at the top there. But the important things are that it must be maintained and they should be linked to detection devices strategically placed around the structure to provide the earliest possible detection of fire. Okay, step 8, protect emergency escape routes, the 35-metre rule. Again, this rule isn't specific to timber frame, it's a general rule, but I wonder how many of us actually consider this when we're designing a building or working on site. A window, as an example, in each apartment can provide an escape route as long as it goes onto a scaffold and then down through a ladder. But the way the system works is you've got 35 metres to either an escape stairwell or the ground. So if you're looking at, let's move on. So at ground level, the maximum distance for any place of work to the outside of the building cannot exceed 35 metres. So assuming a 3-metre high unprotected stair from first floor level to ground level, the maximum permitted distance of travel on the first floor to the stairs is 32 metres, so 32 plus your 3 metres down your ladder. Unless you create a fire escape route down through the building, which can either be internal or external, but it has to give half-hour fire protection down through. That way, your 35-metre rule applies to the head of the stairs. Again, so if we're looking at a high-rise building, a 12-metre high building, if you're looking at, well, we are 35 metres, 12 metre up through the stairwell. If it's unprotected, you can only have a travel distance of 23 metres to the head of that stair route. If it's a fire-protected staircase, again, the same rule applies. You can have 35 metres to the head of the stairs. Okay, again, building in fire protection from the beginning. This is something that needs to be done at design stage to a degree. It sounds onerous, but in actual fact, most buildings are naturally divided up with separating walls and party walls. Flats, for instance, you're unlikely to get a run of panels or a distance in a building within sort of 20 metres without a natural fire break, a separating wall. But it's something that needs to be considered in the design process. Again, subdivision, what I'm talking about. And the subdivision doesn't have to be walls lined with fire protection boards. It can literally be rock wall, as we're seeing there. And there are a range of different types of materials, fire blankets, all sorts of materials that can be used in that situation to create a fire break. Okay, the biggest factor with fires throughout our industry is arson, by far. So guidance should be sought at the earliest stage from the local fire service and police on the risks of any particular location. Again, if we're building on the Isle of Wight, our risks are limited. As a general rule, sites must be kept secure at all times. Access ladders of stairs to upper levels must be made secure at the end of each day. Other possible access points such as windows should be made secure as early as practical in the construction programme. Early plasterboarding and fireproofing of the ground floor level is also recommended. Recommendations can be given on a range of security solutions, including the safe storage of materials and site staff training, and CCTV and overnight lighting could be introduced on larger projects. And to help assess what security features are most appropriate for a timber frame site, refer to the risk assessment flowchart in your documents. Okay, sorry about these steps. Some of them are obvious. Temporary buildings on site. Temporary buildings and accommodations such as site huts, offices, materials stores should be protected and ensure they do not create an additional fire risk. There should be a 10-metre fire break between each temporary building and between them and the building under construction. And on timber frame sites, the fire break should be an additional 10 metres, taking it to 20 metres, or it should comply with the additional criteria referred to in the Joint Code of Practice. Another obvious one, storing equipment safely. Safeguards must be put in place for the safe storage of all combustible materials, flammable liquids and LPG cylinders. Highly combustible materials must not be stored within the building construction. Again, fairly obvious, I would have thought. The Joint Code of Practice gives details of how and where to store these materials and the appropriate signage. And storage areas on all timber frame sites must be at least 15 metres from any building, not just the timber frame building that's being worked on. And containers and drums must not be stored within 6 metres of any building or boundary fence unless the boundary is a wall with at least 30 minutes fire resistance. If you're using bean bags or fall arrest systems, they have to be fire retardant and they must be removed from the site when they're no longer needed or being used. Okay, another obvious one applying to all building sites, design out hot works where you can. And generally speaking, this means that any such work must not be carried out within 2 hours at the end of any working day in case there's embers or whatever burning. So again, a fairly obvious one, which I'm hoping you all already know. And good building practice in general, but also to help mitigate a potential source for a fire is to keep your building sites nice and tidy. Again, the same applies to plant and equipment. Petrol, diesel power plant should not be used inside a timber frame building during construction unless absolutely necessary. A timber frame building must be protected from any heat generated by working plants. So again, it's the common sense factors, I think, come into place with this sort of thing. No smoking. Again, I don't need to really explain that one. Okay, I mentioned site security, which people always sort of think, oh, that sounds expensive, having to have a full-time guy on site at night. Well, it depends on, again, the guidance is there as guidance, and you've got to weigh up where you're building and whether there is a risk. But again, the Timber Frame Association has given some guidance here. So, for instance, if your timber frame was over your 600 square metres, 3 stories or less, and had a maximum overall plan dimension of less than 50 metres, it would recommend a security package A. The same flow chart, but with a distance around the perimeter of more than 50 metres, it would recommend a package C. So just to let you know what those recommendations are, you're looking at a security package A, which is what you should all have anyway, I guess, a non-climbable perimeter fence and lock site and building access outside of hours. But then if you go to the extreme of the security package C, you're looking at CCTV, permanent security lighting, and an out-of-hours watchman, and all ground floor openings sealed. That sort of security package, in my eyes, would only be really necessary in a really built-up area where there's been a history perhaps of arson. But yes, that's the guidance. And the final stage is, as I've mentioned before, is the handover. When the timber frame supplier has completed his scope of works, he's basically handing it over to the principal contractor, saying that we've finished our work, that we're recommending that he keeps the fire plan and any fire breaks in place that were put in place for the timber frame. And then we close, we tell the UK TFA that we've finished our responsibility and we've handed that responsibility over to the principal contractor. So I'm sorry if that was all a bit wordy and techy, but hopefully you're a little bit more aware of the fire risks with timber frames and all types of building construction. And as I'd like to go back to what I said earlier on, it isn't just all about timber frame. Most of what I've spoken about today is legislation and guidance from documents that are not related to timber frame, but all types of building construction. So, any questions, guys?
Going to the sheathing, the external sheathing,
yeah.
Fireproofing, is that becoming legislation or is that just good practice?
At the moment, it's guidance only. All of what the UK TFA produces is guidance only, but I think it will become commonplace. At the moment, there's several different boards out there. Thermosal is one that we've used in the past in these situations, which is a very dense board.
Quite heavy.
Quite heavy. Puts a bit of additional weight on the panel. There are other magnesium boards that are sandwiched against an OSB sheet, much lighter, that are being developed at the moment. Some are already in place. The cost of those, I've got to be honest, at the moment it's a little bit high. We're hoping that when the industry adopts these sort of policies and rules as a given, you know, with the benefit of mass production and whatever, it should drive the prices down a little bit. So we don't think there's going to be a massive uplift. And what we've all got to remember as well is this is only for buildings over 600 square metres or 4 stories, which I'm guessing the majority of you guys probably don't do a lot of. But yeah, any other questions?
The regs will have to change.